We ended last video getting our collection view up and running using the new diffable data source. In this video, we're going to go back and clean up the view controller a little bit, especially talk about the weak self and our network call. But that topic requires kind of backing up a little bit and talking about a very important topic in Swift, and that is memory management in Arc with automatic reference counting. This is an important video because this is a very, very common, arguably the most common interview question for iOS developers. They typically ask this during the phone screen when they're asking you a couple like warm-up Swift questions. This is going to get asked like 80% of the time. They'll say, explain memory management in Swift or something along those lines. And they want you to explain automatic reference counting and how you have to use the weak keyword and how all that works. And that's what we're going to talk about in this video. So automatic reference counting. It basically does what the name says. It keeps account of a reference. So what is a reference? When I initialize an object, here's a developer object, for example. Say I create a developer object with the name Sean. That has a reference of 1 in memory. And what Arc does is it keeps count of all the reference, automatic reference counting. And it cannot deallocate an object from memory unless that reference count gets to 0. So again, I create this developer object. I create one called Sean. Reference count is 1. Sean goes out of scope, or I make Sean nil. The reference count goes to 0, it can be deallocated from memory. So that's the basic example of when the reference count is always 1. However, what if you throw a little curveball? So I have my developer object, Sean. Now let's create another object that is of type MacBook that you see here. We'll name that Space Gray MacBook Pro. And then a MacBook has a property of an owner. And I'm going to make that owner equal to Sean. And then also in Sean, the developer has a property of a machine. And that machine is going to be the MacBook we just entered. So now you can kind of see we have strong references pointing to each other. The MacBook has a strong reference to the developer object Sean, and Sean has a strong reference to the MacBook object called Space Gray MVP. So you can see there's 2 strong references pointing to each other. So for each of these objects, the count is 2. Remember, automatic reference counting, we're counting each reference. So what would happen is if just Sean went out of scope or we made it nil, it would not deallocate because yes, Sean's reference count would go from 2 to 1, but remember, it's got to go to 0 in order to get deallocated from memory. So that is how a memory leak happens, right? We think we made Sean nil. We think Sean is gone, but the MacBook still has a reference to Sean. So Sean is not there, it's stuck in memory, that is a memory leak. So how you fix this, if we go back to our objects, you see in our MacBook object, we have the owner. You can make that a weak var. Put the keyword weak in front of the var where you declare it. Now that won't create a strong reference. It'll create a weak reference. So now Sean's reference count will only be 1. Even if the MacBook points back to Sean, like we talked about earlier, because it's a weak variable, the reference count won't increase. So now when Sean leaves scope or Sean, gets made nil, now Sean can be deallocated from memory because that reference count never went up to 2 because the MacBook one was weak, like I said. So that is automatic reference counting in a nutshell. Again, super basic examples. We're going to talk about a real life example here in our network call and why we have to use the capture list of weak self. But before we do that, back to that common interview question. Of course, I can't give you the exact answer. Every interviewer is going to be different. But if you can just explain how it keeps track of a count and how 2 objects can have a strong reference to each other, and that way the count can never go to 0, and that's what causes a memory leak. And then if you can say the fix for that is to, on one of the objects, make it a weak var, like we discussed. And that might be enough to pass that answer, or you can go deeper. You can say that's what it is in general, and then you could say like a common example of that would be on a network call, where we use self in the closure of the network call. So you have a strong reference between the network manager and the view controller. So now you need to make that weak, and that's a very common example. I think if you just rattle off the last 30 seconds of what I just said, high likelihood you're passing that question with flying colors. And on a side note, don't just memorize that and regurgitate it, like actually understand what's going on. That's kind of what I meant. Just a side interview tip, you should never just be like reciting what you read, right? You should understand what's going on. Because if you just have that little 30 seconds memorized and you just repeat that back, once they ask you a question, and you just have no idea how to answer it, that's probably not going to be a good look. So actually understand it. Don't just memorize what to say. So let's dive into our code here and start cleaning up this follower list VC. Because I cleaned up this view to load in the last video, there's actually not much cleanup to do. Let's clean up that spacing there. But we are going to address, like I said, we're going to address the weak self here in our network manager network call. And then we're going to refactor out the 3 column flow layout. because we're on the topic of memory management, weak self, all that, we're going to start with the network call. So let's take a look at our network call, right? We have our network manager.shared. That is our network manager, right? Where we have our network calls. So right now, our network manager has a strong reference to self in the closure here. What self is, in this case, is our follower list VC, right? So our network manager has a strong reference to our follower list VC. So this could cause a memory leak. So back to the solution, we would like to make this self a weak variable. And that's where the capture lists come in, where you do the open bracket and you do weak self. So this is essentially making self weak. And anytime you make something weak, it's going to be an optional. That's what all these errors are saying. So the fix for this is to, I'll even do the fix it so you can see, is to make it an optional. So make self an optional, right? Because self could be nil now that it's weak. So this takes care of your potential memory leak. Now, I don't like all these question marks and unwrapping. Now we're dealing with all these optionals. This line was introduced in, I believe, Swift 4.2, and it's an interesting line. I don't know if any other line in Swift is like this, but it's all Swift keywords. Guard let self equal self else return. Oh, there we go. So we're just basically unwrapping the optional of self. So now we don't have to have the optional values all down here, right? We've unwrapped it with that guard statement up there. And again, this was introduced in Swift 4.2, basically for exactly this purpose, right? This is, or at least this is where it's the most used. So now we have our weak self and we are unwrapping that optional to make sure we actually have it. And then we're going through and using this. So in all of our network calls, this is called a capture list. And basically, remember weak made this an optional? You can do unowned as well. And essentially what unowned does is it basically force unwraps the self. So you don't have to like unwrap it yourself. It's a little more dangerous. Weak is pretty much the answer you're going to use all the time. To be honest with you, I've never even used unowned. So couldn't tell you. I'm sure there are use cases to do it. Maybe that requires some further research, but I mean, weak self is pretty much the answer most of the time. So that's what we're doing here. We have our capture list. We're making the reference to self a weak one, which again makes that an optional. So that's why we have to unwrap the optional here with this guard let. Again, introduced in Swift 4.2 for pretty much this reason. And now we're good. We're safe from the memory leaks when it comes to this network manager. So that cleans that little bit up, and you'll see we'll kind of do this again in future network calls because we're going to make a couple more throughout the project, and hopefully that will kind of reinforce the idea. So the other thing we want to do, or the last thing I should say, to clean up this view controller, I'm just kind of double checking to make sure I didn't forget anything. Oh, one little thing I like to do, again, just for neatness, again, because it's just a one-line thing. I like to do that there. You don't have to do that. So now let's get rid of this. We're not getting rid of it. We're just moving it. So you remember me mentioning in the last video or 2 videos ago, I like to have a file called UI helper, because when you're building a big project, there's a lot of like little stuff like this. Sure, you could create its own file for each type, but what I found is it's usually like a one-off thing, and I just kind of put them in there. Again, project organization, highly subjective. If you would like a separate file for each type of UI helper, cool. I usually have just a UI helper in utilities that I kind of put these in. So Command N, Swift file, hit next. And again, UI helper.swift, create. So let's create the struct, struct UI helper. And then I'm just going to kind of copy and paste here. So let's go to follower list VC. We've got to yank you out. So X, Command X to cut. And then take that down, go back to UI helper. We're going to paste this in. The first thing we're going to do so we don't forget is make this a static so we can access it. So basically all UI helpers have it. So you can just do UI helper dot create 3-column layout. We need to import UI kit. So by the way, I think I mentioned this earlier, but if you just import UI kit over foundation, UI kit brings in foundation. So if you're importing both of them, that's redundant. So what you're seeing here is I don't have a view that a lot of this math is based off of. So we're going to have to pass that in as a parameter. So create 3-column flow layout, and we'll do in view, and we'll pass in a UI view. And that is going to return the UI collection view flow layout. So this error should go away. Yep, nope, build failed. Where did my build fail? Oh, I think, yeah, because back here on our follower list VC, this doesn't know what this is. So we'll come back to that. So anyway, that's all we really had to do to get this out of here. So we have a static func, so we can call UI helper dot create 3-column flow layout, and then we'll pass in the view. And then because we named this basically the same name that was here, we don't have to change anything. If we would have named this like super view or something weird, whoops, wrong button. Now we would have to name this super view. I just wanted to do that so you illustrate so I can show what I was talking about. But we're just going to call it view because super view is irrelevant there. So now all this code will work, except back in our follower list VC, instead of calling just create 3-column flow layout, we want to call UI helper and then dot create 3-column flow layout. In view is the view we're passing in, the UI view on the view controller. Remember, it's blue, so that's like kind of the default one. So this is the view of the view controller. Do a Command B. Build succeeded. Get rid of that error. So we'll run it again just to double check to make sure everything is working. But you see, we yanked out that huge chunk of code into our UI helper method here that just gets rid of all that code. And let's see if it's still working. Should be. So SALEN 0400, get followers. And there we go. Still working just fine. Our flow layout looking good. Nothing changed. Again, we just abstracted the code out of there to get rid of it. Again, back to the whole philosophy, right? Does my view controller need to know about this? View controller did not need to know about that. So we yanked it out into a UI helper and then just called the function on that UI helper, passed in the view. Everything still works. And you see, we just cut out like 10 lines of code from our view controller. So right now the view controller is only at 81 lines and looking nice and neat. We're going to add more to this, but you can see how neat it looks, readable. Everything's good. So our follower list VC is cleaned up for now. We're certainly not done with it, but that wraps up this video on Arc memory management. Very important. Like I said, this is if you're doing iOS developer interviews, this is almost 100% going to be asked at every single one. Like very, very, very common. So if you watch this video and you're like, I kind of get it, watch the video again and then go read some blog posts, and it'll all click. And I'll link to some documentation here in the description as well. So see you in the next video.